This is the minute minder, and as you can see, it is a digital clock that can count all the way up to 60 seconds before resetting. Now, how does this work? To understand that, it's important to understand how the passage of time works and how the counting of time works, more specifically in the digital world. In the digital world, time is kept mostly using a quartz oscillator. A quartz oscillator, when provided with a current, resonates at a rate of 32,768 times per second, or 32.768 kilohertz. Now, one could notice that this number is a power of 2 to the 15 to be exact, meaning that if this is divided down, one can reach 1 hertz, which is very easy to use in a counting system. Now, to do this, one should use the 4060 IC, which is a counting chip. Whenever a clock signal is presented at the clock pin of the chip, it counts, and depending on the passage of time between either 2 to the 4th and 2 to the 14th ticks, a signal is presented between Q4 and Q14, meaning a frequency could be divided by up to 2 to the 14th time. Now, this still leaves you with 2 hertz. Now, to get that additional division, one could use the 4013, which is a flip-flop chip which could be used for multiple things. However, when a clock signal is provided at the clock pin, Q1 attempts to match that frequency and takes 2 ticks to present a high, which is exactly 2 hertz. This is the exact schematic for the build, and this is the actual breadboard prototype of the build. Now, moving on, one could use the 4518 chip to actually begin to count this frequency. The 4518 chip collects the clock signal at the clock pin and then counts it up using binary. For example, if the number was 7 count, then all pins 3, 4, and 5 would be presented with a high. Now, this doesn't exactly count in the decimal system or more sexadecimal system that we need to count for 60 seconds. Luckily, the 4518 has this capability when chained together. Just put the clock pin in the enable of the unit side and then connect the 8 to the enable pin of the tens chip, and it will begin resetting at 10. Now, moving on, it's still not complete because it needs to reset when the tens pin hits a 6, so 60 seconds. To do this, one can use an AND chip, more specifically the 4081, which has 3 AND chips, providing the 2 and the 4 at one of these AND chips, and taking the signal of that and connecting it back to the reset of both. Now, finally, one needs to construct the manual reset button. To do this, one could use a pull-down resistor combination, where normally a momentary push button is connected to ground. However, when it is pushed, all pins are connected, and it's connected to power, which is then connected to the reset of all the chips, as can be seen in the schematic for this process here. Additionally, this is the breadboard prototype for this section. Now, this signal still needs to be converted and encoded for a 7-segment dual LED display. To do this, one could use the specific 4511 chip. Now, the 4511 chip takes bit data from pins D0 to D4 and converts them into 7-segment LED data from pins A to pin F. This is the process of connecting this signal in both the units and the tens side. And this is what the final device should look like after being connected to a 4511. Still, however, it cannot be connected to a 7-segment LED display because a resistor needs to be used. Otherwise, there will be too much voltage and it could get damaged. To do this, because having a specific resistor for every pin would be too much, you can use compact resistor networks. Now, resistor networks are sets of resistors, as can be seen here, where every pin is a different side of a resistor. Now, these resistor networks can then be connected to the 7-segment LED display. Ultimately, the outputs of the 4511s are put into the resistors and then finally brought to the 7-segment LED display. This should be how the device looks like after this point, and that's the reset button in action. Now, for the final PCB, it is quite simple to solder everything up. However, it is important to remember that after soldering the leftmost section of the PCB, one should check the hertz at the 1 hertz test point and at the ground to see that it's actually 1 hertz before continuing. And then after doing so, one can complete soldering and finally understand and finish the complete minute minder.